Ready.
Good morning, class. It's good to see you. Thanks, Cooper, for holding the camera. Turn it around so they can see you, Cooper. Ah, there's Cooper. Ah, that's good. All right, they got your face on there, Cooper. All right, so we're going to teach lesson 10.6. If you have your books, turn to page 498. 498. We are on almost page 500. So I'm going to teach you a dilation. Now remember, we had talked about 5 different transformations. Those 5 different transformations all were important, and they were important for a certain reason. And the important reason was that each one of these, the first 4 I gave you, did not change anything about that transformation. So the transformation is when it changes. Remember, a reflection was to flip, a translation is to slide, a rotation is to turn, identity transformation is the same. Now, the last one is a dilation. I did write it down for you. And so this is the 5th one. Now, there's something different about the 5th one that's not the same about these other 4. These other 4, they always stay the same in size. Dilation changes size. So make sure you have that down. And so here are the words that define a dilation. Enlarge and shrink. So get smaller. Get bigger, get smaller. Okay, those are your 2 options. Okay, now, what we would have is called a scale factor. The letter that represents a scale factor is a lowercase k. So if a lowercase k is greater than, k is less than, k is equal to. If your scale factor, now, scale factor is a fraction. So that means it's going to get bigger or smaller. If the scale factor is greater, then is the drawing going to get bigger or smaller? Let's think about that. If it's a bigger, that means it's above the 1, so it's something over 1. So that means it's going to get bigger. So greater than 1, it's going to get bigger. If it's less than 1, it's going to get smaller. And if it's equal to 1, it's going to stay the same. So when your scale factor is important. Why? Because the bigger it is, the bigger that scale factor is, k equals x. Let's say k is equal to 5. That means it's 5 times bigger. K equals 10, it's going to be 10 times bigger. If it's k equals 1/2, that means it's going to be half the size smaller. That's what a dilation is.
What's smize?
Now, so here's what we have. So we'll talk about this. So everybody get dilation, enlarge, shrink, scale factor k. K is greater than 1 is bigger, k less than 1 smaller, k equal to 1 the same. Now, so let's go ahead and let's talk about what this looks like. So, okay, let's say we have a drawing here. And I want to draw it here. So let's think about this for a second. If this is a dilation, how much bigger is this triangle than this triangle? So as it's getting bigger, so if this is the original, and this is the new one that you're creating, how much bigger is that? So one of the ways you can do that is measure it. So that's 1. So how many markers is it? 1, 2, 3, 4. So it's 4 times bigger. So your scale factor is going to be equal to 4. K is equal to 4. Your scale factor is 4. So if this is 5, what's this one? 4 times 5 is 4 times bigger. 4 times 5 is 20. This one's going to be 4 times 4 is 16. 4 times 3 is 12. So it's a scale factor. It's going to be scaled bigger. Every side is going to be increased the same amount. The same amount. And that's the goal behind that. So all you're going to do is make it bigger. So what happens if my constant, my k, my scale factor is 1/2? So then it's going to be half the size. So half of 5 is 2.5. Half of 4 is 2. Half of 3 is 1.5. So if your scale factor is 1/2, it's going to move backwards. If it's bigger, it's going to move forwards and bigger. All right. So that's how you would do it. All right. So look at example number 3 in your book. You have your book. Go to your book. You'll see example number 3. It gives you 2 triangles. Okay? Cooper, your arm getting tired yet?
Both.
Okay.
It's been
All right.
5 minutes.
So so it looks like this. A, C, B, and that's 12. And then this one's really longer. Oops. And it's C, A prime, B prime, C prime, B prime. So, and this is 30. Now, so let's think about this for a second. If I want the scale factor of these, okay? If I want the scale factor, how would I solve it? So, this is the image that's created, the new image. And this would be the pre-image. So what's the fraction I would use to solve for the scale factor? Because we know, everybody knows that 12 is bigger or smaller than 30. What would you say? Smaller, right, good. So it's smaller, and we see that this is prime, so that's the translating. It's going to be going from here to here, so that's the transformation. So here's the fraction you use. For scale factor, there's a fraction, and this fraction you will use is, it's going to be new image over the pre-image. So once again, what's the pre-image? This first one without the primes, and the ones with the primes is the image. Okay, so now here we go. So 30 over 12. You can reduce that. When you do, reduce it by 6. It's left with 5 over 2. Well, that's your fraction. Okay? So that's your scale factor. 5 over 2, that means it's going to be 2.5. Good job, Coop. You got it right. All right? So Cooper was mouthing the correct answer to me. Thank you for your help. So that's how you would solve for the actual scale factor if you had it. Okay? So what you're going to be doing in this next lesson, in the homework you're going to do in a second, is you're going to tell me if it's getting bigger or smaller based on the scale factor. You're going to solve for the scale factor. You're going to solve for the scale factor using this fraction, or you're going to tell me what it would be if it was getting bigger and the scale factor was this. So let's practice. Let me show you one. Now, the one thing that is important here is this, that you need to remember this, that despite the scale factor, the angles never change. You never change the angle still stays the same. So let's look at this triangle. A, B, C. Let's say this is 40, let's say it's 60, just to make it easy. 60, 60, 60. This is going to be 10, 11, and 5. No, it can't be because they're 60s. So let's just do it right. All right, 10. So, I have a new triangle created right here. It's A prime, B prime, C prime. The scale factor is 4. So, can you help me? If AB is 10, what would A prime, B prime be if the scale factor